Welcome back to A-Star Science, part of our GCSE Must Know Chemistry series. Today we're talking about phytomining, and phytomining, of course, is related to the extraction of metals from their ores. So ores are minerals that contain valuable metals. And ores do not only contain these valuable metals, but they may contain other things. So for example, if we have iron oxide or you have copper oxide, these contain oxygen, and you only really want the metal ions that are in those ores. And so you need to be able to extract them in some way. Now, as a refresher, remember that when you look at the reactivity series, those metals which are below carbon can be extracted via reduction with carbon. And you can watch my other video on reduction to understand that. So these are extracted via reduction with carbon, whereas those above carbon, such as aluminium all the way up to potassium, you can extract it via electrolysis because they're just too reactive, and so reducing with carbon will not work. But there are other methods of extracting these metals as well, one of which is phytomining, the other is bioleaching, which we're going to talk about in this video right now. So phytomining, phyto, the word phyto, as is pretty clear, refers to plants, and obviously the word mining refers to extracting of valuable minerals such as metals. So phytomining is the use of plants to extract these metals, particularly from what we call low-grade ores. So if we have some ore, which is basically rocks containing the minerals, let's say we have, for example, copper oxide, and it's a low grade ore, it doesn't contain much of those minerals, okay? Or if we have spoilings are the leftover after extraction from a mine. You may have a big pile of these low grade ores or spoiling, and companies know that there are valuable minerals in there, but there's just not enough to really warrant using carbon and other really energy intensive practices. So in this case, they can use phytomining as a particular method, which can be helpful. So what they do basically is you're going to grow plants on top of the soil or the areas which contain the low grade ores. You see my image of a tree that's going to grow onto those low grade ores. And as a result, the minerals, the plant is going to take up minerals. As we know, plants contain a lot of minerals that are very useful for us even in our health. Okay, like iron and copper, all these things can be taken up by plants. And so these plants are going to take up these minerals through things like active transport, and they get concentrated into the plant, and then they can use that. So that's the first stage, that plants are grown on the low-grade ores. And so this leads to one of the disadvantages, which we'll talk about in a minute, that this process takes quite a long time because you have to extract lots of the low-grade minerals from these low-grade ores, and that takes a long time for the plants to do that. Once that happens, the plants are then going to be burned. So they're going to burn the plants to obtain the ash. That's what they really want. They've burnt off the carbon, that's turned to carbon dioxide, but the ash remains, and a lot of that ash contains a lot of those particular minerals. So step number 3 is, how do they get the minerals out of that ash? Well, they're going to dissolve the ash, normally in an acid solution. And that means now the minerals are now within a solution base. So they're now liquid, meaning that the ions are now present. Okay, so the ions are present now of the particular mineral that you want. But they still need to get those ions and concentrate them. And they can do 2 things. They can do electrolysis to extract the mineral ions, or they can use displacement. So they can use a displacement reaction with a more reactive metal like scrap iron. Now, the reason they would use scrap iron is because scrap iron is much cheaper. So this is their method for how they would get the minerals out of that acid solution. But now let's look at the disadvantages of this particular process. There are some advantages of phytomining, of course. The advantage is that it's going to reduce the need for new supplies, okay, for new supplies of ores. And of course, we know that ores are extracted from the environment through mining, and mining can be quite harmful. So this can obviously be a benefit to the environment by reducing the mining, the impacts from mining. So this is really important. And mineral ores are in limited supply. So this conserves those limited supplies. We call that finite. So mineral ores are finite, and so this helps to conserve those limited supplies. There are also disadvantages that we need to consider as well. So what are the disadvantages of this particular process of phytomining? The first one we mentioned already is that it takes a long time. And of course, we know in business, time is money. So it takes a long time, and that means it's going to be quite a long time until the companies can actually get some profit from extracting those particular metals. Number 2 is there's not much minerals obtained from this process. So it's really not always economically viable to use this process, because the amount of energy and time that you're going to put into this process compared to the minerals obtained really won't be as valuable as you would like. There are some other drawbacks as well. You can use lots of energy in the electrolysis process. And of course, we know that energy relates to cost, and so that can be quite expensive. And at the extraction phase, very harsh chemicals are used to dissolve the ash, and that also can lead to environmental problems as well. Please make sure you like and subscribe to the channel. Let me know if there's any particular video topics that you'd like me to go over.